Ladies and gentlemen, good afternoon and welcome to today's BayesiaLab webinar. Thank you for joining us. Let me introduce myself. My name is Stefan Conradi and I'm the managing partner of Bayesian USA. And given today's date, it's a special occasion. I would like to extend a very special greeting to our Chinese friends and colleagues. Gong Xi Fa Cai, wishing you all a very happy and prosperous new year. I realize we have quite a number of folks who are either of Chinese origin or who have currently logged in from China, so our very special wishes to them. So let's talk about what we're going to explore today. Or rather, let me give you a little bit of context first. You may already know that this webinar is part of a new webinar series we've started last week with our very first webinar in this series. Today we're talking about analyzing the 2016 General Social Survey. Next week we're carrying on, going back to predictive modeling, talking about predicting injury severity from automatic collision notification data. And then finally, March 2nd, we will turn to a problem that has no data whatsoever. There we will talk about probabilistic reasoning under uncertainty, exclusively based on domain knowledge. So to register for any of these webinars, please go to our website, Bayesian.com/events. But now let's talk about what we're exploring today. We are already in the middle of the introduction. I'll tell you a little bit about who we are and what we do. I'll address some of the most frequently asked questions. And then we get into motivation and background. It's really all about understanding the diversity of American opinions, and we will try to do this on the basis of the 2016 General Social Survey. And really, today we want to focus on the practical part of all this. So we want to show you how we can go through an entire workflow and what the best practices are in that context. We'll start off with some data preparation. I'll show you how we can bring in data via a software called Stat Transfer. And then for the rest of this webinar, we will talk about the BayesiaLab workflow per se, going through data import, missing values, processing, all the way through ultimately analyzing and trying to understand what we found through machine learning, a Bayesian network. So just real quick, for those of you who are perhaps logging in for the very first time, you will hear the term Bayes over and over again this afternoon. Let me perhaps clarify that nomenclature. Bayesian, that is our company. That's who I work for. BayesiaLab, that is the product that we're talking about today, the software we see in action. But most importantly, really, we are employing the Bayesian network paradigm. That's really the background to everything we're exploring today. This is our modeling framework. It was invented by Professor Judea Pearl, who's been teaching at UCLA since 1970. And really the motivation for him to invent Bayesian networks was that the way he saw it at the time was that algebra was too limited to encode causal relationships in problem domains. So he was thinking of a new way of encoding relationships that also allowed to formally encode the causality part. And so he also coined the term Bayesian networks. Now, for the longest time, Bayesian networks remained inside the world of computer science as a very useful technology, particularly in the world of artificial intelligence. But what we want to do, and this is really the principal objective of everything we're doing, of all of Bayesia's activities, and that is we have translated this mathematical formalism into a research software, and more generally into a research workflow that makes Bayesian networks useful and practical for many researchers, not just computer scientists, but biologists, economists, pretty much any field of study you can envision. And really, what we need to bear in mind is Bayesian networks can be generated a number of different ways. One is we could use our domain knowledge to encode a Bayesian network. That's what we will do that we will do 2 weeks from today, when we are talking about encoding to domain knowledge. Now, today it will be all about learning knowledge from data, machine learning from data, and thus generating a Bayesian network model, which we can then use for analysis, simulation, diagnosis, optimization. In our application today, we will primarily use it for clustering and segmentation. So the software that you will see in action is BayesiaLab. That's our principal product that allows you to machine learn Bayesian networks from data. We'll see how we can edit such networks, how we can perform inference, how we can analyze, simulate, optimize, all on the paradigm of Bayesian networks. One thing I would like to emphasize, BayesiaLab is really a laboratory. It's a laboratory for your problem domain that allows you to really comprehensively encode your problem in BayesiaLab, and then within BayesiaLab you can work your problem backwards and forwards until you have a thorough understanding of it. Now, BayesiaLab is really part of a suite of software packages. Even though we're only going to look at BayesiaLab Professional today, there are academic editions, education packages, we have an API, a web simulator, code expert module, and there are many other components that you can utilize and that extend the principal desktop software really into an entire ecosystem of applications. But as I said, today we'll just focus on BayesiaLab Professional. Let me proactively address some of the questions that always come up. If I can get the slide to move, just bear with me 1 second as I'm waiting for PowerPoint to react. Here we go. Yes, it is actually moving. So the most frequent question that we always get is, can I have these slides? Yes, you can have all the slides. Those will be made available for download after the end of the webinar. Another common question, can I watch this webinar again? Perhaps you want to watch it again with your friends and family on a Saturday night. Of course you can. We will make the recording available and shareable. Perhaps more importantly even, yes, you can also try this out yourself. We have a trial version available of BayesiaLab. In fact, there are 2 trial versions. One is a somewhat restricted demo, but you can also download an unrestricted evaluation version, or rather you can apply for that, and we'll gladly make that available to you for your evaluation purposes. Now, hopefully you will ask this question, where can I learn more? If today's webinar was of interest to you, please consider one of our 3-day courses, which we regularly host around the world. Typically, we're once a month in a major city around the world. Coming up in a couple of weeks, we will be in Dubai. Perhaps for our American audience, might be more convenient to travel to San Francisco, where we will be hosting a seminar March 13th through 15th. So you can learn more about all these events on our website, of course. And then, of course, I couldn't possibly address all questions proactively. Please do feel free to submit questions related to today's topic via the question panel, via the GoToMeeting or GoToWebinar panel that you should have on the right-hand side of your screen. We will not respond online. Rather, we will take all your questions, respond directly to you via email, excuse me, and then also post the response on our user forum at Bayesian.com/community. So you will see the response to your question as well as responses to everybody else's questions on the forum. So let's get to our main topic of today. It's going to be all about understanding the diversity of American opinions. And here I'd like to start off with a parable. You've probably all heard this story about the blind man and the elephant. And this is a story about a group of blind men who've never come across an elephant before and who now wish to conceptualize what an elephant is like by touching it, by exploring it. But as you can imagine, every one of these blind men is touching a different part of the elephant. One is touching the tusk, the other one the tail, the other one the leg, the foot, and so on. So individually, they all get very different impressions of what that elephant might look like. And so this is actually what I feel when I look at news headlines as we are being bombarded in the media with political viewpoints, opinions, analysis, etc. And here I've just selected some snippets, some headlines from various news sources about the opinions and attitudes of Americans on a variety of topics. And, you know, sometimes this is very, very detailed, like this one. I'm just going to read it to you. Among Asian Americans, we find that neither white vulnerability, modern sexism, nor racial resentment are significantly related to Clinton support. And so it goes on and on. There are whole industries that work on analyzing this whole field. But what I find very difficult is, you know, to get a sense of what the entire elephant looks like. What is the big picture here? Now, in order to form that opinion of all of America's opinions in their diversity, I want to draw on the General Social Survey. That survey has been conducted by an independent research organization, NORC, at the University of Chicago. It has been funded by the National Science Foundation, and since 1972, they have asked questions about national spending priorities, crime and punishment, relations, morality, and a wide range of topics, all related in the broadest sense on politics, if you will. So we're not going to look at the entire data set today. The entire data set is quite big, primarily in the sense of the number of variables that are available. The 2016 General Social Survey includes 960 variables and has a total of 2,867 survey responses. We are only going to look at a subset of those variables for our purposes today. We're looking at 130 variables related to politics, role of government, civil liberties, morality. But to keep things simple for us, we just want to capture opinions, just what people think about other things. We don't really take into account anything what people think about themselves or any of their attributes such as demographics, etc. And in this context, I should also mention, this is not going to be a piece of research that we're going to publish. This is strictly a story that we want to utilize to illustrate the BayesiaLab methodological workflow. So our selection of variables is principally for convenience, and the samples and the selection of weights, etc., may not produce necessarily a representative view of the US population. So none of what you see today you should really interpret as a research finding. It's simply the backdrop to us applying our BayesiaLab research workflow. Now, even though we're looking at the big picture, or let me rather put it this way, as part of forming our big picture of America's viewpoints, here this is an interesting question, and that is, well, is the diversity of opinions that we have in this country, is that adequately represented in Parliament, in our case in Congress? Because one could perhaps argue there are other countries, for instance, think of the Indian Parliament, where there are many, many more parties and many different factions that represent their particular positions on a wide range of topics. So this may be an interesting thing to explore today. How many opinion segments do we actually have in this country? How small do we have to divvy up that pie to capture everybody's views? Now, here we're asking this question in the context of politics, but of course, for market researchers, it's the very same question. So this is really a prototypical question, because market researchers need to understand, how many consumer clusters are there, how many individual segments should we cater to, how many different products should we build to really have a good fit of our services versus their needs. Now, what is also quite prototypical about our approach today is that we have many variables, including what I would call legacy questions, because many surveys, like the General Social Survey, have evolved over years. And with every iteration, additional questions are being asked by new researchers. So you get different concepts, you get inconsistent scales, you get categorical, numerical variables, ranges, and so on. But one of the things that is very, very common is that there are lots and lots of missing values. In our case, in our data set today, we have 33% missing values. And here I want to be precise, because there are different types of missing variables. And to give credit to the folks at the General Social Survey, they have very clearly distinguished these different types of missingness. For instance, they have inapplicable variables, or the state inapplicable. That would be relevant, for instance, if you were asked at what age did you get married, if you have never married. In that case, that would be what we call a filtered value. Now, fortunately, in today's data set, that's not part of our data, so we don't have to look at it. Then we have the type of answer don't know, which some may be tempted to consider as missing, but that's not really missing, because rather that is a distinct non-numerical state representing that this particular respondent is unfamiliar with this particular question. So that is a distinct state. And the remaining two, inapplicable in the sense of was not asked or no answer, those we really need to consider as missing proper. And those require treatment as we proceed to machine learning a Bayesian network from data. Now, we could spend a lot of time now talking about missing values. of course, we don't have that in the limited amount of time this afternoon. So I would like to refer you to our book, Chapter 9. There we talk in great detail about how to deal with missing values and what methods are available in BayesiaLab. What you will see me do in practice is how we can employ these missing values processing algorithms effectively. Anyway, so let's proceed to our main workflow. And just one thing I would like to point out here, and this is really a unique selling point of BayesiaLab, the research process, the research workflow is very quick. And so what you will see today is everything we do is in real time. So between now, 1:22 and 2 p.m., we should be done with the entire research workflow. And I think that is representative of how quickly you can work with BayesiaLab. So let's now get to the data, which is freely available from the GSS website. And looking at the screenshot here, it looks like Woody Allen is downloading the data. And GSS makes all the data available in two formats, in SPSS format and I believe in Stata format. We're choosing the SPSS file. And there is now a very convenient tool that allows us to take all the information in the raw data file in SPSS format, including long variable names and value labels, and transform that into a format that can be completely brought into BayesiaLab without losing any of the metadata. And this is really an important aspect of working with BayesiaLab that we have not really touched on in earlier webinars and seminars. And that is something that makes life for the researcher really quite convenient, because we can manage all the metadata related to a data set in BayesiaLab with dictionaries. So we can manage node classes, long variable names, short variable names, node commons, which could represent complete questions from a questionnaire, state value labels, etc. And these dictionaries are simple text files that link up individual variable names with full variable names, with commons, etc. Here you see just an example of some of the variables that we will be utilizing today. In the same way, we can assign state labels to specific variable codes. And this is helpful because often you may need to recode variables or reverse the scale of a variable, etc. So here you can do that, and you don't have to erase the original value. You simply relabel it and process it that way. In BayesiaLab, we go way beyond just managing node values and node labels and comments. Pretty much all attributes that you see in BayesiaLab, attributes of arcs, nodes, states, you can manage via dictionaries. You can manage the position of nodes on the screen. You can manage the images that should be associated with nodes, and so on. It's really a very comprehensive system that makes research so much easier. But I wanted to mention that up front, because now as we shift over to BayesiaLab, we will use that, and you will see that in action. So I will leave PowerPoint now. If I can get out, where is my end? Okay, hold on. Here we go. Okay. Finally managed to get out, and now you can hopefully see the BayesiaLab screen. This is the starting point of our exploration. At this point, we are going to open up the data file that we had previously exported via stat transfer from SPSS. So here initially we see a data table preview with all the variables. And this data file I've already pre-processed a bit, so we don't have to select missing value codes, etc. any longer. I've done that beforehand, but had I not done that, we could now specify what codes relate to missing values, filtered values, etc. So I'm going to step through the data import wizard, and we can see that all the variables that we have in here in this data set are categorical. They are already in discrete states. That's how they were recorded in the original survey. Only the very first variable here labeled weight, that is numerical, and as the name implies, that is our weight variable that we're going to use. So I've selected that. Going to the next step, this is important, as I said earlier, because we have so many missing values. And now I'd like to point out a few things here. Let me see whether I can highlight that. Here in the information panel, you can see a number of measures. We can see how many rows, how many columns we have in this particular data set. But this is important because this shows us how many values are missing. In our case, 33% of our data set is missing, which translates into almost 120,000 values. That needs to be imputed as we go through learning our model. So let me just move my GoToWebinar panel to the side, which is currently obscuring my screen. Hopefully you can see that, but it's blocking my view here. So okay, now by default, most often we would choose the structural expectation maximization algorithm as the appropriate tool for missing values processing. And that's a very, very safe choice. However, computationally, that is quite demanding. And before we have a sense how long the learning takes, we kind of want to approach things conservatively. So what I will do, instead of selecting the structural EM, I will select the entropy-based static imputation. This will make our research workflow a bit faster because I will have control over when the missing values processing takes place. So I can request that ad hoc as opposed to BayesiaLab performing this automatically, continuously in the background. So next step, there is nothing to do, there is nothing to discretize, and with that, I will click the finish button, and all our variables now appear as blue nodes, as these little blue disks on the graph panel of BayesiaLab. By default, under the little disks, we see the short variable names, which, given their brevity, aren't particularly explicit. So first thing I will do is I will use our dictionaries and associate node comments with our variables. So this gives us the ability to bring up kind of complete long variable names. Now let me just stretch this out a little bit, in addition to the short variables that are on display by default. So for now, let me turn it off though. Additionally, I will need to associate node classes. This gives us the ability to also formally link up the state labels and value labels that were originally stored in SPSS. So let me go to this and now associate state names. Here we go. And now if we open up any nodes, we now see that in addition to the original value codes, we now have the state name, or we have a name, an interpretable name for each state in each variable. So that's done. We could now immediately proceed to learning, but I'll do one more thing. I will add yet another class variable and use it as our principal set of classes. I will add a class that delineates our subjects. So, and that I had defined earlier, which now gives us a class for each topic. So here in this case, one subject is abortion, affirmative action, civil liberties, confidence in institutions, questions about the economy, education, and so on. So I will actually ask BayesiaLab to apply colors to each of these topics, to each of these classes, so we can more easily distinguish them. So each group of classes is now, or each group of nodes is now connected in a class and is colored according to the class membership. This also gives me the opportunity to very easily select subgroups that I'm interested in. In this case, I want to remove a group of variables. More specifically, I want to not remove, but rather temporarily exclude all variables that relate to party membership and specific voting behavior. So I will right-click here on Party ID, and I want to now select all the other variables that are in the same class. So I select that. You see that the node that refers to the presidential election in 2012 is also selected, and the node that refers to political views. For now, I want to exclude these three. We will see how we bring them back later on. And for now, I will also not just exclude them, but I will hide those excluded nodes. Okay, so let's return to our original question. Well, how many major groups of viewpoints do we have? How many opinion segments do we have in here? Now that we've excluded our variables, we have, let's see how many variables we have left. We should have 121 variables available. Given their sheer number, it would not be possible to directly perform a clustering on those. They're just way too many. So what we will do first is we will perform unsupervised learning to create a Bayesian network, and then use that network for clustering to induce variable clusters that perhaps provide a simpler picture of all these underlying manifest variables. And on that basis of that simpler factor structure, hopefully we can then perform a good clustering into segments. So let me zoom out. Here are all our 121 nodes, and I will go straight to learning. And here in this case, I will use the Soplec learning algorithm. And after having selected it, you can now see how BayesiaLab has now learned a first network. But given that I have selected a static missing values imputation algorithm, I now need to prompt that. Now that we've learned our first network, now I need to tell BayesiaLab, okay, now on the basis of that first network, please estimate out the variables or the missing values again. I can prompt that by selecting parameter estimation. So BayesiaLab runs again. You can see the progress bar at the bottom. Should just take a few moments. And once that completes, we will do another run of unsupervised learning. And in practice, we would probably repeat this a few more times until kind of the network stabilizes, and then we can move on that basis. But having tried this out a little bit earlier, this is actually a significant time savings as opposed to running this automatically with each iteration. So let me just run this one more time, and then we should be good to move on. So, and before we actually start our clustering, we want to get a sense of, well, what does this structure mean that we've learned? What you currently see on your screen is probably not very intuitive. So I will first use a two-dimensional layout algorithm so we can get a sense of the structure that BayesiaLab has machine learned. Now, of course, we see lots of arcs on the screen right now. They're crossing over each other. So it's not particularly easy to get a sense of what is happening. Also, here's a big bag of nodes kind of clustered together. So let us perhaps first try to untangle that a bit. But as you can see here in 2 dimensions, that's a bit tricky. So I'm going to activate our 3D mapping, which is a very, very practical tool because it gives us the 3rd dimension or a 3rd dimension to spread apart these nodes. Now, initially, as you see here, this network is as flat as a pancake, but by prompting our automatic layout algorithm, we can now untangle that, and now this becomes a 3-dimensional structure that becomes much more easily to interpret. And just out of curiosity, just as part of our exploratory process, I'm going to turn on 2 measures that can perhaps help us interpret this structure. And the first one here is node force. It shows that now the size of the bubble, the size of the node is proportional to the node force. And the arc thickness that we see reflects the strength of the correlation, and blue and red also show us the sign of the relationship. And you may perhaps wonder, what is this big blue bubble that we see here? That seems to be quite dominant, and node force is really a measure that tells us how important a particular node is in the context of the entire network. That big blue node refers to feelings about the Bible. So that theme, this will keep coming up as we continue our exploration today. But you can see even this 3-dimensional visualization really doesn't do this network justice. It's still quite complex to see and not easy at all to interpret. So this is where we can also go into virtual reality. And some of you may have seen our seminar where we demonstrated how we can now take a network like this, export it, and then explore it using the virtual reality with the Oculus Rift headset and the touch controllers. But given that this is a webinar, of course, I can't share this with you. But just so you know, this is also something you can certainly try out on your own. All right, let's proceed on our mission. we wanted to induce factors that represent all these underlying manifest variables. In BayesiaLab, we can simply start this variable clustering via the variable clustering command. That has just, we've just run that. And now you see that the colors of the nodes have changed. Now they're no longer colored as per the original class assignment, but they are now colored according to their cluster membership. We can visually explore it directly here on the plot, or I really like to use the dendrogram. This may perhaps be a bit small to read. That shows you how our nodes clustered together, and I can also experiment with how many, with the number of clusters. So what BayesiaLab proposed, I think it was 27 clusters, was just a proposal. I can certainly override that with my own domain knowledge and say, well, this is more appropriate. So the dendrogram is one way of exploring this. Also very useful is the bubble chart here, our mapping function, because we can now explore interactively and merge and disaggregate these factors until this is in sync with our domain knowledge. So it's interesting when we boil it down to a single factor, theoretically, interestingly, that would boil down, the most dominant variable would be feelings about the Bible. Now we have lumped together 121 variables into a single factor. But of course, we're not going to do this. Let me return to BayesiaLab's recommendation of 27 factors. I will accept that and save that. And now I get a report that shows me how BayesiaLab clustered together all these manifest variables into factors. So with that, we can now proceed to what we call multiple clustering. We can now formally induce these newly formed clusters, these newly formed factors into our network. So, and in BayesiaLab, this happens, we can prompt this with the multiple clustering command. And there are now a whole lot of settings that I could talk about. Given our time constraints, I will refer you to our book where we talk about all these settings in detail. What I should point out here is that we don't know yet how many states each of these factors should have. So we will leave that for BayesiaLab to determine. So let me run that. This should just take perhaps 30 seconds or so. At the bottom of the screen, you see a progress bar. And then once that completes, we will get a new graph panel that shows us the newly created factors surrounded by their associated manifest variables. It should pop up momentarily. Okay, here we go. In fact, in order to get to that, I need to perform the automatic layout to bring order to what looks a bit chaotic initially. So here we now have our factors at the center of each of these flowers, if you will, and surrounded by and each factor is surrounded by the corresponding manifest variables. Okay, so good. Now that we have 27 factors, now we can attempt to perform clustering on that basis. And that will, I think, be quite interesting, because that should get us much closer to the answer or the question, or to the answer of the question, well, how many major viewpoints exist in American society. So let me go back to our clustering menu and now select data clustering. This will now attempt to cluster these newly created factors. I will skip talking about the individual settings. You can learn more about those in our book. Rather, let me run this. It will just take a few moments. And then momentarily we should have a report that gives us the result of this particular search. BayesiaLab is now trying to attempt to see whether 2 states, 3 states, 4 or 5 states would be the best fitting summary for that newly created factor node. We will see the answer soon. We see how the report progresses via the progress bar at the bottom. Seems like BayesiaLab is keeping us in suspense. Okay, where is it? Here we go, finally. Here is our report. And again, we will look at other aspects of this to interpret the report. The key point here is that it seems BayesiaLab found 2 states for this new cluster that summarizes all the factors. So BayesiaLab says this appears to be the best solution. Okay, how can we interpret that or validate that? First of all, let's lay this out in a nicer way. I like in this context the radial layout. I think this gives us a good sense of, oh, looks like we somehow omitted a variable here. I'm not sure whether I accidentally deselected it or why. Gun law, certainly an important topic, was omitted. I'll have to explore later why that wasn't included. It was probably just something I forgot to click or accidentally deselected. So here is now our principal factor at the very center. This is the cluster that represents the factors in this inner circle which represent the manifest variables here in, if you will, the outer circle on the periphery. But now I really want to know, what does this central factor with 2 states, what does that really mean? How should we interpret that? And in order to see what it stands for, I want to see how this factor relates directly to our manifest variables. So I will now exclude, at least temporarily, our factors here in the inner circle and learn a relationship between what was given the name factor 27, our overall clustering variable, and I want to see how that relates to all our manifest variables. For that, I learn a quick naive Bayes network. Of course, that requires our factor to be designated as a target node. Of course, and one more thing I forgot to do is I forgot to remove the forbidden arcs, which are automatically generated through the multiple clustering. Hence, the naive learning didn't immediately work, but now that I've removed the forbidden arcs, it should work here. So let's just update this view, this radial layout view. Okay, and stretch this out again. And now go into the validation mode and see what these two clusters, these two states stand for. So in order to get that sense, I will now bring up our monitors and sort them by target correlation. And I will furthermore turn on the full variable comment so we can see what each stands for, and I will also widen the monitors so we can see all the states of all the variables. So to analyze, to see what our overall cluster stands for, these two segments, I will simply click on each of the states. Here I'm now on C1. I don't know what that stands for yet, but now I'm going to look at the monitors, and I see this would suggest, and the red ones here, they all, or here the first one refers to abortion, whether or not I would accept abortion, or whether I would accept being not married as a reason for abortion. And it seems like of those who are part of cluster 1, the answer is no. For that group in C1, also feelings of the Bible, there is a high percentage of those who accept the Bible as the Word of God or the inspired Word of God, and so on. So I can look down and really see what states of the variables are associated with our overall factor states. So let me switch to C2, and you now can easily observe that it changes around. Now abortion seems to be okay, and the percentage of people feeling the Bible is a book of fables has gone up. So we could look at all these manifest variables, and you can probably quickly get the impression that C1 appears to be associated with more conservative viewpoints as opposed to C2. Here we seem to have more liberal or progressive sentiments. At least that's my kind of quick interpretation, just looking at the monitors of these manifest variables. Here another example here, when you look at military spending, gay marriage, and so on. If you will, this is actually, you would almost say this is quite stereotypical as what we would expect of someone who labels himself or herself as liberal versus conservative. But I would now like to more formally explore that. Let me delete all these variables again. And instead of using my interpretation of liberal versus conservative, let me bring in what people say about themselves, because that too was a question in the 2016 social survey. So I now want to understand whether factor 27 that we generated automatically from all the viewpoints, how the states of that factor relate to the political views, the self-assessment of the respondents. So I have now manually connected our factor node to political views. Let me bring up the full name. The full name or the full comment of this variable is think of self as liberal or conservative. And I will run the parameter estimation and then go back to the monitor panel and then bring up factor 27 and then bring up the monitor for political views. Now that we only have two nodes here on the screen, we can make this larger. And now let me experiment again with the states C1 and C2. Let me toggle back and forth. And now you can see as I click on C1, the conservative side goes up. As I click on C2, the liberal side goes up. There's actually a nice new function in BayesiaLab as of version 7. It's called absolute and relative variations. There I can see how my distributions change as I am setting evidence. So as I'm setting evidence on factor 27, as I'm toggling back and forth, I can see that cluster state C1 is clearly associated with the conservative side. The conservative side goes up as opposed to cluster state C2, which appears to be strongly liberal. So what did we learn here? Well, what I found quite interesting about this example is that it seems we have very quickly recovered a structure that is in sync with our view, with kind of our current political situation in the country. We have a mix of roughly 50-50 of these two states, which we could label conservative versus liberal, and we have quite easily recovered that in a relatively short period of time. So I'm not saying that that confirms that in the US we only need two parties, but it seems at least based on the questions that we have selected from the General Social Survey, we could very quickly and easily recover a structure with two major segments. Presumably, had we included other questions, perhaps on taxation or more on civil liberties, perhaps a third cluster would have emerged, a third segment that may represent perhaps an independent party or a green party or who knows what. So just wanted to show this to you as a workflow, how from survey data through a clustering process we can quite quickly get to a segmentation that in our case turned out to be quite plausible. So let me now briefly return to PowerPoint to wrap up our session. Just bear with me as I'm making the switch here. And as I'm scrolling through, you can see here that I have screenshots of all the steps that I've performed live. I have screenshots of that in the PowerPoint. So when you look at it, you kind of have a documentation of each individual step. So let me just quickly speak to where you can learn more about BayesiaLab, in particular licensing options and pricing. That's available on our website, as well as on our online store, store.bayesian.us for the North American market. You'll also see links for the European market and the rest of the world. And as I said earlier, all the responses to the questions that you have posted throughout this last hour, they will be posted on our user forum, and you will also receive an individual email with the response. Now, if all of this was, or at least some of this was of interest to you, I would very strongly encourage you to join us for our introductory BayesiaLab course next month in San Francisco. We've rented a fabulous venue. It's actually the old Federal Reserve building that will be hosting this course. So great location, great venue, a great teacher. Dr. Lionel Jouff will fly in from France to teach this course. He's the co-founder of Bayesian and really the brain behind BayesiaLab. So that's really the best way to learn about BayesiaLab. And then looking a little bit further ahead, towards the end of the year, we're hosting an annual conference, which this year will be in Chicago, November 1st and 2nd. That's a great opportunity to not only hear from us about BayesiaLab, but from many others, from researchers across different fields of study, different industries, everybody from military strategists to cancer researchers, marketing scientists, really a very, very broad spectrum. I always find it fascinating because I hear many different use cases and learn about many new applications of Bayesian networks and BayesiaLab. So I would like to thank you for your time and interest. I would love to continue the conversation with you. Please connect with us via Facebook, Twitter, LinkedIn, etc. Shoot us questions by email. We'd really love to hear from you. But for now, thank you so much for your time and interest, and have a great weekend.